So thank you very much, Dr. Katz. Thank you very much, Dr. Herbert, for inviting me for the introduction. It's a pleasure for me to be here. I'll try to give you a few ideas, take on messages about concerning science and diplomacy. So Science Diplomacy 101, life lessons from scientist and diplomat, work in progress. I think this is the most important thing. Okay, so what I'm going to tell you, I believe it's true, but it might be wrong. In a few weeks, I'll say, ooh, I was wrong. Okay, so I'm trying to provide you my most accurate findings, but they will be updated as things change. And so this is a part of the scientific process. We think something is right. It doesn't mean it is right. It is right at the moment with in the system that we are, in the environment that we have, but that might be wrong in a few weeks from there. Okay. Right. So a brief introduction. And then we'll start with part one, science diplomacy, and part two, longer one, life lessons. And we'll try to finish with a few challenges. It's open to discussion. So a brief introduction. As Daniel said, so I'm a scientist that started with physics. It was in Toulouse, France. Then in Lyon, another place in France. And then I went to Montreal and Grenoble at the same time, so 3 places, Lyon, Grenoble, Montreal, to start applying my knowledge in, this was physics applied to cardiology at the time. Then I didn't say that, but I became a teacher of physics and mathematics, and did my postdoctoral fellowship in the Netherlands, and then back to France, that's the UB. And then I used a very interesting program that we have with the EU, which enables us to teach abroad within the EU, or for students to study abroad within the EU, right? So I had the chance to go to the University of Barcelona to teach a number of topics. And also I got a grant to go to Norway and establish connections over there. After that, I became a visiting scholar at the State University of New York before becoming a scientist and a diplomat for the Ministry of Foreign Affairs, Europe and Foreign Affairs, as an attaché for science in the Embassy of France, the US. And I will let you know a little bit more about that. So this was the different institutions. Here, this is more what I've been doing in terms of maybe levels. I started when I was in Lyon at the level of the individual, right? Population dynamics and things like that. Then I focused on the heart, and maybe a part of the heart because the heart was too complex. So I cut the heart, and actually, literally, I cut hearts when I was in Montreal doing animal experiments. Then I studied heat shock proteins, certain types of proteins when I was in the Netherlands, and went always to a lower level of detail. So more details going to the nanoscale, and even to the angstrom, and providing this structure of protein that was important in cancer. And when I did that a couple of years ago, I had this exam to become a full professor, and I actually took this slide from my presentation. And I said during my presentation, I've been doing that, but now I think I need to come back, right? And this is what I did in a few years without really realizing I was doing that. And this is why I left the lab somehow to come back to the population dynamics. It's always complex systems, but it's different. And I realized that for me, I was somehow using a bias, and I will talk about biases later on. My biases here was reductionism. You have a problem, you cut it in small pieces, and you solve the pieces, and then you still have a new problem. It's not a problem, you cut it into pieces that are smaller and you solve the problem. And it was very interesting, but I realized that maybe I forgot the whole picture, right? So I said, I need to do something more global, okay? This is just my personal journey. It doesn't have to be everyone's. So as Daniel mentioned, I have a few patents. Some are in the US, others are in the EU, European Union, a few brands and beta tests, etc. And I wrote a book which is Practice of Science, and very recently another one in statistics. I will talk a little bit about these books, not to bother you, but to explain my kind of journey. And statistics can be boring, but it can be also very interesting, actually. So the first one is about the practice of science. Actually, because I was studying or sometimes working in different laboratories across different places, I realized that there were a few trends, a few common patterns that struck me at the time, and so I started writing this book. In many instances, people think that a scientist is someone with a lab coat, glasses, a microscope, and tubes, etc. Right? We all have this kind of archetypal image about science. It really is very different from that, right? And so this is why, even though a colleague of acquaintance drew this very nice picture, I had to redo it because now it's more done by students, and there are, social networks, and the dynamics are very different. And we spend a lot of time behind our computers, more than behind the tubes. And more recently, okay, one important point there was that I realized writing this book, so not so long ago, that as a scientist, as a community of researchers, we produce a lot of papers, okay? Many, and the more often is considered, the better. I didn't think like that, but it's commonly what people tend to think. And so many papers, scientific articles, but they are not very accessible to the main audience because they are technical, because you have to pay for them often. They are in English, not everybody speaks English, right? And probably another important fact is we don't have the incentives to read scientific papers. You don't have like a slot in your agenda say, hey, you have to read something interesting in science, right? We have a lot of things to do, and we don't have time to investigate what has been published already, apart from a very focused project, right? And so that's the reason why I published this other little book, not even 2 weeks ago or something. So it's in French. Both of them are for the moment. I'm sorry, but that's the way it is. I translated the title. Actually, statistics are numbers are everywhere. Okay, we could count students or people being here in the room, for instance, or make statistics about the age or the color of the hair or whatever. So it's easy to do that, but we can also do statistics with text. Right? Word cloud is nothing but statistics with coming from text. Okay? So statistics, they can be everywhere, but we don't spend a lot of time teaching statistics. And I can tell you I was a math teacher at some point, right? We don't spend too much time. And I think statistics are very important because they are everywhere. And we have a computer scientist, I think one in the room, he won't complain, right? Numbers or data is everywhere, but we need to be able to access it and make sense out of it. And so this little book is telling people how to use a simple spreadsheet and a few easy tools that are free to take advantage of these technologies that are actually available, but we don't spend too much time on it. but to run your house, know your expenses, you can make statistics. Very simple statistics. And maybe there will be another book, number 3, which will be started here with these lessons. Okay, a few things that we need to pass, a few messages. Okay, so maybe a few of you have been to France already. If not, this is France. And actually, there are a number of places around, a number of islands, right? I'll talk about France and Europe. So Europe, or the European Union, okay, is a kind of federation, a group of 27 member states that are shown here, right? EU was awarded the Nobel Prize, Peace Nobel Prize, and the population is about 447 million, okay? And to give you a little perspective, here is a table that I made to, okay, because when we are in Texas, we don't realize maybe, well, already the US is plenty of, and then you might consider Mexico and Canada, right? And that's already a larger space. So populations, 2967, USA is 332, EU 447. In terms of surface, okay, the EU will be half, more or less, whatever the metric or square mile system that you will use. And the GDP will be fairly comparable in terms of, I will put one of that I'm sure. Okay, just to give you an idea, because people think about a lot of, I hear a lot about the US and China, but there is also Europe, which is a very important player. We have very long-lasting historical bond EU with France, France with the US, and US with the EU. And so it's important to try to make this bond as healthy, as strong, and dynamic as possible. So science diplomacy. Quickly, what is diplomacy? Do you have an idea what is diplomacy? We're in a Diplomacy Institute. Do you have a, can you come up with a definition? Not you, but a simple definition for diplomacy. Do you have any idea? Okay, to facilitate. Yeah. Do you agree with that? It's okay between countries, correct? Yeah, okay.
And between people, of course.
And between people.
Like
okay.
public diplomacy as well.
Right. Okay, that's a very nice definition. Thank you. So, this is one definition. The art and practice of conducting negotiations between nations. Okay, that's the very first one that we can have in mind. And also, interestingly, skill in handling affairs without arousing hostility. Okay, that's an important one. So that's diplomacy. And actually, the French network of diplomats is here. You can access it with the web link. I will provide you the slides. And so you can see that the French diplomats are everywhere, mostly everywhere. And we have the third largest diplomatic network. Okay, so the first one is the US, China, and then we have France. It's a long-lasting tradition. This is why many words in diplomacy are actually taken from French. Okay. Diplomacy can be with different flavors. It could be economic, humanitarian, cultural, science, and, for instance, sports. The Olympic game can be seen as a way of connecting people, whatever happens, almost. whatever happens in the nations. Okay, connect people on a larger level. Houston has 19 sister cities. Somehow this is also a way to connect people. Okay, I didn't find for Clear Lake, but I'm sure you, I didn't find it. Doesn't mean that it does not exist. So different ways of using diplomacy. And here is another thing about diplomacy, the Paris Agreement. It's about climate change and decarbonization. And this is also a way to connect people, okay? Connect on a common objective. Economic diplomacy, this is to give you an idea of the many French companies that are actually in Texas, right? So you may have heard of some of them, but I'm sure there are a few that you didn't know were here. And you can see the number of jobs created by French companies here in Texas, okay? And the numbers of the billions of dollars that are traded annually. And so this is economic diplomacy. It's very important. It's often one of the very first one to be, you know, activated. You can see here the exports to France will be 4.7 billion, and Texas imports from France 3.3 billion. So similar range, but different things. Okay, Texas tend to export energy products and to import transport equipment, for instance. Okay, so I'll give you the slide for you to read and enjoy. And you have a number here also, US to France and vice versa. So it's interesting to see the amount, but also the types of products that are exchanged. And as I'm involved in technology, and which means also startups, I'm working with different entities within the team France, including French Tech. This is a network of people that are working with startups. Okay, and so you have a few numbers for you, okay, and also employment by French companies by state. You see that Texas is the top of the list, right? Voilà. And so the Team France is composed of many entities that are here in Houston. My colleagues from cultural part, Campus France. If you want to study in France, you may contact them. They have sometimes opportunities for students. Business France, obviously in the business. This is if you have a company here and you want more connections, and this is the Consulate General. So these different players are interacting with their counterparts here. Okay, so diplomacy, we talked about it, and now science. Actually, what is science? Can we come up with a simple definition of what is science? No? Okay, so I will use this little book. So Richard Feynman, I don't know if you know this person. I'm sure. I'm sure, but okay. Richard Feynman was a very famous American physicist. He was also a Nobel Prize winner, right? He worked a lot about electrodynamics and quantum theories. And he wrote this very interesting book, The Meaning of It All. And it's very nice for me as a physicist to be holding this book now here in this Institute of Diplomacy. And I will skip maybe this one. No, okay. Okay, so before the definition, it's interesting to know how much people are aware of science and they are, you know, thinking that it may have a positive, a neutral, or a negative effect. Okay, so this is a study made by the Pew Research Center in Washington, D.C., and they publish a number of very interesting surveys. This one is about science, and you see that mostly people tend to think, if we look the larger bin, people tend to think that the effect of science is mostly positive in the US, okay? Really, according to the respondents. And the trend is more or less stable, 67, 73, 67, 65, okay? A few things that is neutral, the amount is fairly stable as well, and a few, very few, think that it has negative effects, okay? Okay, so it's interesting, this is global, but of course, it will be also interesting to know about the details about COVID-19 or any topic that you like, because this slide is a summary rather than a detailed study. But if you're interested, you can dig in using the link below. Another interesting, I would say, graph comes from the Census Bureau, and they provided a few months ago this graph, which shows STEM, okay, science, technology, engineering, and mathematics. There, people, STEM related and non-STEM. This is the bachelor degree, and this is the occupation group, so the job that you have at some point, or when they were surveyed. And it's interesting to see that at the beginning, STEM is not the majority, and it's even less important afterward, right? So as a teacher, former professor, or teacher and scientist, it's puzzling for me, right? Because I would tend to say that we need science in every kind of topic, even if this is not the main topic. Science research can help, right? So this is just a snapshot of the situation. It's interesting to know that. And so just like I was telling you, interestingly, actually science can be defined by three different things. One of three things, or a mixture of them, to quote Richard Feynman. A method, a special method for finding things out. It can be also a body of knowledge. So there was the article, scientific articles I was referring to would be the knowledge part. And also technology, the new thing that you can do, but as he insists, there is no instructions on how to use it. Important, right? We have to define them, and there is a lot of things happening. But so science can be one or more of these three things: a method, a knowledge, and a technology. When you have a phone, this is basically a technology. There is a lot of science into there, but we just press the buttons and we can do a lot. So these three things, and there is a lot of articles. If you use Lens, which is a free and open database for looking, that enables you to look for either scientific articles right there or patents, you can see the amount of existing patents in this database, 139 million and 244. There is a massive amount, but we don't necessarily have the incentive to dig and say, okay, what about this? Okay, and if you do, the problem will be that you will have a lot of data, and then you have to start, making sense out of it, but selecting, prioritizing the data that's coming. So science diplomacy, there are different initiatives like the CERN, okay? which is a European research organization that operates the largest particle physics laboratory in the world. It's also, interestingly, the birthplace of the World Wide Web, and they have inside this page. We're in Houston. There is the ISS, right? It's a fantastic way to bring people together in the US, Russia, Japan, Europe, and Canada. There is also ITAE, which is a fusion project. So it's an international nuclear fusion research and engineering mega project. It is actually based in France. And it's being in construction. It's being constructed with different partners, right? And fusion is an important way to potentially create energy of the future. Not the point where it's fully commercial, but it's getting there. When you read the scientific literature about what is science diplomacy, it says three things: science for diplomacy, science in diplomacy, and diplomacy for science. This is the three sub-definition within science diplomacy. And many people agree on this definition, but I would say, just like I was telling Catherine, I think communication is a very important part that I don't see there in this definition. Okay, so I'm very happy to have this chance to talk about science and try to convey a few messages. Science for diplomacy is using science cooperation to improve international relations between countries. Diplomacy for science is facilitating international science cooperation, and science in diplomacy is informing foreign policy objectives with scientific advice. Okay, these are three components of science diplomacy, but don't forget communication. Because when you're in the lab, everybody thinks like you, and everybody thinks science is super important. But if you happen to move a little bit away from the lab, it's a very different context. And you might be the only one to think science is important. So you have to make your point, right? And it's not so obvious, actually. Because of the science literacy, you know, there's a slide before of the Census Bureau with the percentage of STEM, non-STEM, etc. Not everyone has a science literacy level that enable people to talk just like you are in the lab. On the contrary, so you have to make simplifications at some point to be able to talk to someone, right? And as scientists, we don't like too much to simplify because we see life as very complex and with nuances, etc. And I will come back to this point. So I'm an attaché for science and technology in the US. We are 8. I'm obviously based in Houston, and I have colleagues that are in LA, San Francisco, Chicago, Boston, Atlanta, and our counselor and 2 of my colleagues are in Washington, DC. Okay, and so the way we work is we have a perimeter, just like Daniel mentioned, Texas, Louisiana, Arkansas, and Oklahoma, and we also have a discipline we're in charge from its physics. For instance, my colleague in San Francisco is about AI, etc. And in DC, we have collaborators from very famous French institutions like the CNRS, which is a very active research institution, whatever the disciplines. Voilà. And we have a few programs that might interest you at some point if you are willing to connect with French counterparts. You can, for instance, contact me. We can chat about that. But we have ways to send American students to France, and also exchange of PIs and students. We're involved with early stage startups. So if at some point you start a startup, it would be
I
interesting.
think there's someone waiting in the room, in the lobby.
Oh, yeah. Voilà. Thank you. And so also what we do is scientific events like Café des Sciences, Science Café, where we talk about a topic of interest and we bring evenly like one French scientist and one US scientist or two, etc. Okay. In order to exchange ideas and try to think what is worth and what are the most important things to do. This is about France and the 70. So we are a much smaller country, a country that is smaller than Texas. And we have about 70 universities. And if you want to know more, you can go on this website. I'll skip that. Well, so life lessons. I think communication is very important. And according to different communities, communications can be more than one thing, of course. The reason why we communicate can be about sharing information, requesting something. It can be about readjusting or protesting, or simply social connection. Okay, this is one study. Another one would say convey facts or information, express feelings, to direct others, to express a need, to form a relationship, to gain knowledge about the environment, to tell story, jokes, imaginary words. So different analysis and interpretation of what communication is about, but more or less you can define and make different items. The vision will be slightly different, but you can actually find the same kind of patterns. Okay, social interactions, regulation. The structure is different, but the content is more or less the same. And it's a bit the same thing when you are having to go through a lot of papers, scientific papers. They say different things. It doesn't mean that they are excluding themselves. Sometimes it's just a culture and they will say something, and they mean the same thing, but using different words. So it takes a lot of practice to try to combine and integrate these different views. So we can express our emotions, seek information, give or provide information, persuade. Okay, are we the only one on earth to communicate or not communicate sometimes? We have a no there. Who does communicate? Pretty much every living thing. Do you agree with that?
Yes.
Okay, examples?
Animals, birds,
Birds, yes.
insects.
Insects, cells, they do. Just in our body, they do. Yes. Other, so humans, mammals, insects. I'm sorry?
Plants.
Yes?
I heard a tree.
Yes, interestingly, trees as well, right? So we think about animals, but also trees. It's very interesting. So we have whales, dolphins, we know them, they kind of make very interesting sounds, or they calm and etc. There is a very interesting movie, a French movie that you see this person here is on the canopy of a tree, and the tree is gigantic, right? You can see the size of the tree, so it's about 10, I don't know how many feet that will be, but about 30, 40 meters. And so a few levels, right? And he's drawing the trees as they grow, and the movie is very interesting too. explain how trees do communicate. When there is a stress, when a tree is cut, etc., the signals that are sent, or if there is an invasion of insects, etc. Okay, so it's very interesting to see we are not the only one to communicate or to try to communicate. There are many species or living things that are also trying to communicate. Unicity and similarity. I think, yeah, I didn't prepare a slide for that, but in many instances, we think we're unique, right? This is correct, but it might be sometimes incomplete. And this is somehow part of my first book, where we think our life is completely unique. It's not true, because there are a number of patterns that you can see. And for instance, you might say, I'm in a lab of this, or I'm in the hospital of this, etc. And this is how you tend to define yourself. That's okay. But someone in another state or another place here in Texas or another country might do the same thing. And you might undergo through the very same challenges. I need a job. I need to eat. I need a promotion. I need to pass this exam, etc. Right? So there are trends, forces that are beyond our just own unity and unity, and makes that our trajectories or our goals might be similar in some ways. Okay? And it's important because sometimes people tend to think that we are in silos. So you have mathematics, you have physics, you have chemistry, and you have the hard sciences, and you have biology, and that is another one, and you have the social and humanities, social sciences. These are buckets, bins, silos, if you want. And people think that nobody else can understand them but their peers or their colleagues, okay? But at a broader level, you can think that, okay, they are studying different topics, but the patterns, you need to get your degree, you need to, if you are hired at some point, you want a promotion, etc. And so there are forces that transcend these different specificities. Hierarchy of needs. I find it very important. That's the Maslow study. It's the study that starts with the physiological needs, safety needs, belongingness, love, etc. And when you're involved in research, which is a very stimulating environment and job, you need to have these already pretty much fulfilled, otherwise it's difficult. It's very challenging. Okay? And research has a time, I mean, the time frame is rather long than short. By the time you find the results, then you need to publish, and it takes another few months or a year, or maybe 3, maybe 4 years, etc. So research has its own dynamics.
There's a revision to that now with
Yes.
the new generation. They say that the first needs are not the physiological needs, it's power and Wi-Fi.
Correct. So everything changes, including this. And actually, I think, so Maslow never thought about a pyramid. It's usually designed or schemed as a pyramid. And I think it's not exactly how I would picture it now. I think that every day we need to fulfill all of them to some degree, right? You don't spend one day eating or, well, this is a mix every day. And if you don't have all of these at some point, you will have a problem, okay? You can add Wi-Fi connection, but at some point you need to be disconnected too, right? It's important. So, so this is just, I was saying, an idea, it needs to be updated, and also what somebody tells you might not be true for you. You can consider it as an advice, a potentially interesting view, but if it doesn't match your own experience, then you might, it could be better to put it on the side and come back to it a little bit later on. Okay, I mean, this is the truth of someone that you're trying to understand, but it might not be relevant. That's all. Okay, when I was doing omics is the analysis of everything you can do about genome, for instance. Try to monitor every single gene in the body or in the cell or all the cells, etc. Okay, we try to look at everything. It's very interesting, but it's also a daunting task. And it's impossible. I mean, there is too much information. There is an information overload, and so we need to prioritize. So my suggestion, when you have too much data, find a way to prioritize it. So this is the Pareto plot. It's an Italian statistician that used to do this little thing, very simple. Instead of putting the data as it comes, or by alphabetical order, which doesn't make much sense, instead, use always the largest bin to start and go in a decreasing order. This way, it's very simple because you just have to look at the very first one, or maybe two, or maybe three, to know what's really important in this study. Otherwise, if you don't do that, if you mix everything, people will try to look at the first one and then they will forget, and then nobody gets the message. Okay? So I would consider trying to go for having the most holistic view, trying to collect all the possible data, but then try a nice, interesting, relevant way to prioritize the data, and just forget the rest once you have the maybe one or two first components or most important parts. Complexity. So according to you, what is complex and what is complicated? We have here a plane and we have a few geese. What do you think? So it's a definition. If you don't know it, it might be tricky. Okay, no problem. So according to the complex system jargon, we might say, a Boeing is just complicated versus a pack of geese, which is complex. Why is that? Okay. Complex means the whole is more than the sum of its parts. And actually, in complicated, okay, you have many parts. They are interacting with each other, but the properties can actually be accurately predicted. And they are able to manage a limited range of perturbations. Okay, the sum is the sum. This is the sum of its parts. More interestingly, complex systems displays properties that are not predictable from a complete description of its component, and the whole is more than the sum of its parts. In our lives, in a cell, and in our human relationships, okay, we can compensate for someone that is not here, etc. Right? So we have functionalities, role, etc., but we are able to change them accordingly. There will be a leader. If the leader is not there, then it will completely change the dynamic, right? And this is these kind of things that are called complex in this framework. And so what you want to do when you have a kind of device like this, or a plane, or a sophisticated product, you want to build, when failure is not an option, you use redundancy. Redundancy can be heterogeneous or homogeneous. For instance, you may have different computers, but also different brands of computers. So you're doing the same thing, but with different equipment. So if one is damaged or has a virus or a bug or something, the other can be there to take over, okay? So this is the kind of thing that you think when you are designing or assessing complex or complicated. Okay, and this is another thing. So this concept was from a French doctor, Claude Bernard, an experimenter, and he designed the concept of milieu intérieur, so for the cells. Then there was Cannon, who generalized that, the ability of a system to maintain itself as an internal equilibrium. And more recently, there was this Japanese person who talked about robustness, which is a way to actually maintain function. So for instance, if I'm walking, okay, I'm walking, this is a state, but if my leg is hurt, I will try to walk, right? I will maintain the function, but I will change, I will have a different state, right? So maintaining the function here, that will be, for instance, going forward, moving, etc. And so we can see these different concepts at play when we are in different organizations, structures. It can be in your home, it could be in your at work. And we have many different types of interactions. For instance, you can have an auto-regulation, self-regulation. I'm trying to see what I'm doing and trying to modify this behavior of mine. But sometimes when you have something important to say, you will try to tell someone, okay, if you're here, if you have something important to say, you will say someone, but also the one that is affected by that, to make sure that the information is passing through the network. Or if it's very important, then you will try to tell everyone. But if you want to be more robust, then you will try to tell more people and to make sure that everybody knows the information. So these are molecular networks, so proteins or transcription factors. So it's within a cell, okay? But these patterns occur in many different contexts according to our scale. Nuances. So I think we need to move beyond the 0-1. Okay, 0-1 are very convenient for computers. We are not computers. And we need to take also into account Bayes' theorem, which says that as things are, as the data change, we should change too, right? We should keep an eye on the data, so the information about a topic, and adapt according to the data, what the data tells us. So that's in essence, the Bayes theorem. The 0-1 version is, okay, let's try actually to think about nuances. It's not here and not there. Our friend here was coming back at first. Okay, so he's not here the whole time. Okay, it wouldn't be described as the 0 and 1. Okay, so we need more nuances. And in science, there are many nuances. And sometimes we need to kind of diminish the number so that we are able to talk about what's happening. Do you see what I mean? Yeah? So good and bad. Is this thing good or bad? Sometimes it's difficult to say just it's good or it's bad. Maybe it's good and bad depending on when you take the medicine or when you do this thing, right? This is a typical example. It depends. It might work for this person, but not for you. Is it good and bad? It depends. And as scientists, we tend to say it depends, and this tends to annoy a lot of people. We're sorry for that. But there are many different variables, reasons, factors that maybe will influence the results. Okay? Okay, classifications. This slide is complex, but what I mean there is that when you make beans classification like hard sciences, soft skills, and other things, it's a classification. It will not be able to, you won't be able to put everyone in a bucket, right? There are places where there is more than one propriety that is shared by an object. And so there are different statistical or AI tools that enable to make groups. And the way you make groups, actually, well, the method that you use to make groups will impact who is in the group. For instance, if we want to make the blue team, we will take the people with a blue shirt or, okay, that will be one team. But if we say, okay, it's not blue, but it's age, or it's glasses or not glasses, it's a completely different set of people that we're making, correct? So depending on the parameter that we are using or a method that we are assessing the people, then we are making every time a very different group. And sometimes a person can be wearing a gas and having a blue shirt. And okay. So groups are convenient, but we should be also aware that it can be very arbitrary, depending on the factors and also the method we're using to make the groups. And it's related to AI, where in AI people were thinking, okay, it is objective because it's the computer that did it. It's not me. I'm subjective, yes, okay, maybe. But the computer did it. The computer is perfectly objective, right? No, because the computer was coded by a human, point number one. The data was provided by people that collected the data, number two, the method, etc. And so we can see that AI is not as objective as people first thought. And this is why there are many debates about ethics and AI, because if you didn't include minorities in your data set, it's not objective actually. You are looking at a subset of a population per se, for instance, okay? So there are many biases that are being discovered, okay? And that's a good point because we're going to address a few of them. If you're not too tired, are you surviving? Yes? Okay. If you can, I will try to provide you a definition and then you will try to provide me an example. Not on this one. This one is to tell you about interpolation, about bias. We see something that is not there, right? We all see a white triangle in the middle. That's not really there. Okay, our brain is trained to fit something when sometimes there is nothing. That can be a trick. There's just a visual bias, but there are many other types of bias. A long list, I won't go through all of it, but I selected a few. I hope there are not too many, but what is a bias? It's a strong preconceived notion of someone or something based on information we have perceived to or lack. It's a subjective way of thinking that originates from a perception or point of view. The bad thing is that a bias can be personal, but it can also be collective. It can be knowingly or unknowingly. So it's not easy. Okay. What are the advantages? What are the pros of having biases? Let me know. It looks like a terrible thing to have. Why do we have biases?
I'm not sure about something.
Yes. It's very convenient because it's fast. Up, a little bias, and you have an answer. It's a shortcut. So if you use it, you're fast. It doesn't mean you're right. It can be really wrong, but fast and happy. So there are many biases. We have to be aware of them. If we don't know them, how can we spot them, right? It's impossible. So, anchoring bias. When we rely too heavily on the first piece of information. Say this device is $3,000. Next time you see it 100, say, ooh, it's either a cheap one or etc. Okay, so the first information counts. This is a bias. If we can be more flexible to that, that will be an improvement. Cultural bias. So when we perceive other cultures as being abnormal, outlying, etc., we are the best. And the others, okay, do you have examples of that?
Social biases.
Mm-hmm.
Now, of course, French people eating croissants.
Yes. Is that a problem?
No, we're just talking about like, no.
Okay, so cultural biases are easy to encounter, right? In-group bias, it's similar, but it's the type of bias that people are more likely to support or believe someone within their own social group, okay? And I told you a little thing about complex problems where you have many players that interact and the interaction change as a function of time. When you're willing to solve complex problem, the in-group bias is very problematic because we actually need more people that have diverse views. That's what we want, right? It's a way to try to be escape the bias, right? If we have different angles, we will have a more complete, holistic view of the problem, and we are more likely to find a right solution. So in many companies, people are actually looking for diversity of thinking, right? It's about gender, it's about age, it's about your curriculum, etc. So the more diverse your team, even for a project, okay, it's always better to take someone, work with someone who is very different. Of course, there will be conflicts or different views of the same thing. Things you thought would be obvious will be super complicated to admit by the other, right? They will say, no, I don't agree. And so you will have to explain many things, but in the end, you will come up with something much more robust. And this is also what they do in startups. Why? When they are making, sometimes they are just making groups of 2 people, maybe 3 people. They are combining not just 3 medical doctors, right? It wouldn't make sense. But there will be 1 MD, 1 engineer, and 1 business person, for instance. Okay? It gives you different ways to look at the problem and try to provide solutions. Sometimes they also add a kind of a layman, someone who is completely away from this field, doesn't know much, and they will ask very naive questions that are important, because sometimes when we're too specialized, you tend to forget the very basic needs that people have, right? So it's very important when you're trying to solve complex, real, concrete problems to have a diversity of minds and diversity of people. The selection bias. We notice things more not because it's more abundant, but because something has happened to make us notice that particular thing. So I think there is a nice quote: "To a man with a hammer, everything looks like a nail." Okay, so you want to head everywhere. You have one tool, you want to apply it everywhere. It's not necessarily relevant, but it's so convenient. You have it. Let's use it. Okay. So this is a selection bias. Easy to find. Do you have your own experience? Have you experienced it? You have a little something to say about this one. For example? Example of selection bias, where you had something you didn't know it existed, but somebody pointed to you, and then you could see, well, you could see it everywhere.
For example, usually companies prefer to hire young people because they think that it will be easier. They will stay longer in the company. They will be efficient right away and not get sick and not have too many leaves of absence and things like that.
Okay. So
Maybe
that's
that's a selection bias.
So that's a bias, but there will be one that will be even closer to this one you're describing. The bias, sometimes they are, depending on the categories, just like I was telling you, depending on the authors, etc., they change. But you make a point, it might not be the best bias, but it could be too. Yes?
So, I mean, if you're looking at a tool, for example, I guess if you're a qualitative researcher, you might always look at the problem in a qualitative manner. If you're quantitative, see, you always look at it statistically, but there could be another solution or another
Exactly.
cause variable that's completely outside of the statistics that makes all the difference in the
You're
world.
right. Absolutely. So if you're a quantitative researcher and you try to apply a quantitative solution to this problem, without thinking what is the problem and is there a qualitative way to tackle that, that's a bias. Okay? Exact. Thank you. Another one. So tendency, the confirmation bias, quite obvious, quite frequent. The tendency to search for, interpret, favor, or recall information in a way that confirms or supports one's prior belief or value. So you know something and you just want the data that fits perfectly to what you knew already. No, I told you. I told you. That's typically something where you don't really update with the current data, whereas we should with the Bayes theorem I mentioned. Okay, so do you have examples? Feel free. Have you experienced that? You can just say yes or like that. Yes, you see what I mean? Okay, let's do that. Cherry picking. So cherry picking is when you actually select data and you discard the trend to get the little part of it. So for instance, if you have, I don't have a pen, but okay, if you have a lot of data points here and you have two out there, instead of considering these two like a bit strange, okay, you would consider that these are very important and the most important of it all. That will be cherry picking, especially if in advance you said that the trend should be up. It's not. Imagine it's just right there, but you say, hey, I told you there are these 2 points. Okay, this is typically a cherry picking, and it's related also to the other one. Huh? The halo effect. So when you think that one thing is great and you just think that the whole thing is great, okay, it's just like a generalization in a way. Instead of one thing, generalization. Do you have an example of that? Have you seen this before? Have you realized it? Yes, no? A little bit?
Sure,
Pretty
anytime
much.
you have somebody who's an expert, let's say Stephen Hawking, and you think, well, he bought a Camry, so he must know what he's talking about.
Yes. This kind of thing, right? It's a bias. Convenience sampling. So as someone who taught statistics, I'm very sensitive to this one. So instead, when you want to know something, you have to sample. That means that you have to ask the question to many different people, diverse people. Oh man, okay. So the thing is that non-probability sampling, what you do instead of doing that is just you ask your friends or the people that are nearby in the corridor. Oh, I did my survey. Okay. This is a bias because the people we work with, we go or practice sport with, etc., they are already part of some kind of a community. And therefore, they tend to share common traits, common thinking schemes that we need to have. It's not the same thing as going to a mall, 9 a.m. and asking people until 7 p.m. or something, right? That would be a more objective way, trying to scan the whole potentially the whole different list of persons. And here, randomly drawn numbers of people would be more helping, right? Using dice or some kind of random number, generator of random number will help to figure out which persons. So instead of doing that, you could make a list of people, assign a number of them, a number to each person, and say, oh, this is 9, so 9 is this person, and I made a 6, and this 6 is this person, etc. That will be already much better than just asking the closest person, the lab next door, or something. Determination and randomness. So determinism is A causes B. I have to take this. So 5-minute recess. Is that okay? I'll be back. Yes, hello.
Oh, is it the same thing?
Well, it's not pricey. And the other ones were COVID-19 cherry picking.
Yeah, it's my chance to stretch.
It's winding down. We're going to talk to the speaker. If maybe before you go, we can do a group photo. If you're okay with it, just make sure you sign in on the sheet. But we'll do that, then we'll wind down. Thank you.
I'll try, I have to. This is a little longer now. Is it? Okay, I'm so sorry. I was just writing my name because of my teacher.
I've never been in this country, but my role.
It's like an education question based on what's in the law.
That's what I was guessing too, right?
Yeah, there's a lot about teaching and pedagogy,
Uh-huh,
teaching techniques, teaching.
yeah. Teaching philosophy.
Honey, how you doing? All right?
I accepted a hard copy.
Staying busy?
He said I could.
Oh, yeah.
After I said I wasn't. I did that business last semester. You don't want to get into that business. That is your responsibility.
Those days well.
Oh, hi, Miss Stephanie.
Hi. Good, how are you?
I keep track of. Okay.
Oh, Miss Stephanie, I have a quick question for you. So, I'm sorry. I became so much better at being very firm. Program, are you able to rip me apart? Okay, and how long have you been in the US?
Because I did say, I was like, I
Okay, so you've been in, okay. So there should be an inter CBT. What?
So determinism is when A causes B all the time. And in many instances in our lives, we have cycles. Sometimes we are recycling problems instead of solving them. But also on a general basis, every day is another day, every week, etc. So we have cycles, seasons, etc. Longer on an annual basis, for instance, etc. Every 10 years, something happens. And on the other side, we have randomness, things that are popping out. We didn't figure this out. This is a nice, by the way, a nice tool where you can put a list and then roll a wheel and it will stop at one randomly of these names. Okay, so it's generating random numbers. In our lives, so there are many, it's often a mix of determinism plus randomness things. For instance, where is the randomness? Where is the determinism in when it's raining? So do you see determinism? Things that always occur? Or randomness? No? Randomness? Why? What's random?
predict the weather.
So the weather itself is rather random, more or less random. The drops, we cannot predict where they will fall, correct? I'm not sure it will be very useful, but at some point it can be. But you know, if your field will be watered or not, if you need to put fertilizer, etc., it's important on a larger scale. So this part will be more or less random, but we could still solve determinism. When it's raining, it will be wet. The water level will increase at some point. Okay, that will be the deterministic part. Or another will be it will stop at some point. Okay, so depending on how you look at the event, there is a mix of determinism and randomness. And I won't click there, but it's a nice tool made by a mathematician that died during the COVID pandemic. It's a zero-player game. You don't play. The only thing you do actually is set the initial conditions, and then there are rules behind that that will make the game evolve. And people have been studying this for a long time, especially Conway. And there are patterns that occur. So it's very convenient. You can draw, you can write your name, basically, and it will evolve. And you will see structures that are sometimes cyclic. They repeat themselves like a cycle, and others that will vanish, etc. It's a very funny thing to do. And I will stop there, I think. Okay? I know for yours. Up to you.
We'll just want to have an opportunity, brief opportunity for everyone to ask questions of the speaker. So yes, please feel free and just raise your hands and but they'll exercise the moderators prior, have Dr. Harrod ask the first question.
You know what? I want to turn it over to the audience. My questions are fairly complex. Let everybody else, if you have questions, this is the time to ask.
I'm just trying that.
The one-player game.
So it's a long initial condition, but let's see what it brings. Voilà. So yes.
Did you on purpose leave the communication that people have maybe with God on the side, and all the randomness and all these things.
It's a
Like
very
some
important-
people believe that things happen for a reason, so I don't know.
Yeah. Okay, it's a very important question, religion and science. Where do I start? So it's a real, I'm sorry, I will. So science and religion, I didn't mention it. I think it's a very important topic. We cannot escape from it. We have to at least think about it. We may disagree, but that's a topic I would like to address next year. Okay, I would like to find people that are in the field. I've done that when I was a student a long time ago in France, in Lyon, actually, where there was a scientist, CNRS scientist, and a priest, and they talked, etc. I think I'll have to do it. Not this year. I cannot do it, but I'll be very happy to bring people, many different religions and many different. And if you are willing to be part of the process, I'll be very happy. If you know people, and there is probably a gap, a chasm maybe between religion and science. It may not be necessary. Eh? I think we can do something. Yes.
Can you talk a little bit about the diplomacy of science and how through diplomacy you're able to promote science or the understanding of science?
Okay. So with my colleagues, I'm not working alone. I'm working with colleagues, and for instance, we're writing, notes, for instance, to our ambassadors or to ministries, and so we're providing input as a scientist. We're deciphering the situation, for instance, COVID-19, saying, no, this is what is happening, and we think this is this, etc. So we wrote many a newsletter article about that, trying to convey the message, our scientific view of what was happening at the time, for instance. Okay. Also, we're working with colleagues to improve, for instance, the exchange of data. It's becoming very difficult from one country to another one. And so we have been trying to figure out where are the most important bottlenecks and how we can circumvent or address these problems. And so we have an internship. My colleague in DC has an internship. We have people that have been encountering these problems, and we're trying to see if we can help them solve that to enable a smoother and fastest exchange of data, for instance. Did I answer your question? Or is there other things in your question you wanted?
Well, I'm interested in, I understand about the bottlenecks. So, for example, I'm over the libraries here, university libraries, and one of the greatest bottlenecks is our method of publishing science papers. As you mentioned before, hitting the paywall.
Yeah.
And so that how can we?
Okay, so that's open science. That's another thing. And so we are doing that more with my colleague from San Francisco.
Yeah.
Okay, we're trying to see what we can do about it. So in France, we can publish a few things. The NIH has been leading in the biomedical arena, where you can actually publish, for instance, in a famous journal, but also make it available on PubMed Central and things like that. So there is a lot of efforts. Myself, I'm promoting as much as possible, and I'm talking a little bit about it in my book. First one, trying to say we need to, and it was a very frustrating moment when I realized how much data was there, papers were there, but inaccessible. And so we have, but this is also related to the economy, the business model, right? And so we have to come up with a different business model. Otherwise, it's not working. So there are a few initiatives, and I publish myself in open access journals to try to do something, because when you're a scientist, you have to pay to have your article not accepted but published, and then people have to pay to access it. This is the current status in many instances, which is not very satisfactory unless you're working as a publisher, of course, right? So things are in progress. It's difficult, but it's a lot about IP. It's a lot about economic issues and important players in the field. And every time we've seen that with Uber drivers and Lyft, for instance, when there is a new economic model that really crushes the preceding one, there is a problem, right? And so we'll see how it goes. We are trying to promote it, to see who is playing and how we can combine the voices. Europe is pushing a lot for open science. There are many initiatives for that. And so we're part of it, obviously. We'll see how it goes.
One of my questions actually builds on that. I'll just advance part of it. But innovation holds promise through collaboration to solve some of the global challenges that we have. The pandemic sort of typified this, and that France was actually a leader in trying to gather information in the early stages of the pandemic. The problem was, then it became a race for a vaccine or a treatment. And there was a sort of a shutting down of, some of the sharing of information, which I would argue had a deleterious effect on treating the world. How do we move more towards those open collaborations and innovation and sharing of data while simultaneously being concerned about IP rights and the whole issue of, the economic issues surrounding these new products, innovations?
It's a very important question that is related to the open access. It's probably even more global, but that's the same problem anyway.
Yeah.
So when we are making a finding, when we're finding something, a discovery, etc., do we need to monetize it? Because we think we are going to have a fantastic startup, maybe a unicorn? Or do we share it and we may lose everything or not benefit at all? That's a very important question. Probably depends on the fields, on the people. Incentives are more nowadays to start your own startup. Obviously, there's a lot of money around the startup ecosystem. It has benefits, but you see how many startups last. It's a very stimulating, interesting journey, but the odds are not fantastic for a startup. At 5 years from now, the startup is likely to be finished, right? So I think we need to address all that in a different way, because it's very exciting to have a startup, to have a spin-off, etc. But we are maybe not. There's probably a better scenario we haven't figured yet, or that would be in between. But how are we paid? It is related to what is the cost that we have, and how do we actually make them? How are we paid? How do I get the money? Do we need a cryptocurrency for your startup you're not making, right? It's a matter of values. That's for sure. At some point, it comes back similarly to religion, I think. Okay? It comes back to values. What are the values that we have? And what are our top priorities? Is that being rich, being healthy, being collaborative? Just like I was talking about when we were in terms of classifications, it depends on the features, the things that you are looking at, and also how you're prioritizing or organizing them. Okay, we cannot all be millionaires. What do we do with the rest? The majority of us, right? So it's a society problem or society question. I'm very interested by this question, and it's about economic models, value. It's difficult to change the values of things and to change in general. Sometimes I see that people prefer to have a sense of urgency to make changes more maybe desirable or efficient. I'm not super convinced by that. I've read a number of papers or books where it's probably more interesting in the long run to make small incremental changes. It hurts less and you have less rebound effect, okay? So I'm not saying we should completely change our values because we wouldn't be able to do it. But if we incrementally change a little bit toward a more sustainable, suitable word for all of us, that will be very interesting. And this is somehow related, of course, to diplomacy, where we want to be everybody to be happy, because otherwise you will tend to create wars or riots, etc. And it's not very, it's definitely not what we want, correct? So ideally, how can we make a society locally and globally that is where individuals are happy, healthy, and benefit from each other, etc.? This is a bit of your question, correct? I think one of the clues or one of the would be education. I think we need to talk about who we are as human. We don't talk about that during our curriculum. And we need to know what we can do, our individualistic versus collectivist behaviors, very important. Where do we want the threshold? How is too high? I mean, some communities will accept this, etc. We need to be more aware of what we are as human. We don't spend enough time, I think. The social sciences are very important. I'm talking here more, I talked about hard sciences. They're important, but we need to combine them with the rest. Okay, I don't want to talk too much because I know this is lunchtime. But this is a very important debate. If you have ideas, please, let's share them. Voilà. I will run the simulation before you leave. You'll see it's kind of cool. Okay, so this is a cyclic behavior, this is static, and this is in progress. Okay, so that's the game of life.
Please,
Voilà, voilà.
warm round of applause. If you don't mind, we could take a group photo at the front before you leave. We appreciate it. Thank you all.
Okay, so let's meet it in the beginning. 4 o'clock is fine for me.
Okay.
And the next one starts at 7.
Yeah.
Uh,
Australia. Too late?
no, that's fine.